Hi Algebra 2, welcome to lesson 90 and lesson 91. The very first thing we're starting with today is something that we did see a couple weeks ago, where we're looking now for x and y and z in three equations, okay? However, it's a little bit different this time because last time they just gave you like one equation that had like an x and a y or a y and a z so that you could substitute and it would be easy to solve all these. Now you have three equations with all x, y, and z, so you're gonna have to get a little creative. Let me show you one thing that we can do. We can combine these two equations, eliminating the z, and get an equation with just x and y. You can see how this is positive z and negative z, and then this is positive z and negative z too, so we can do the same thing over here and get another equation with just x and y, and then work to solve for x and y, and then plug in for z later on. Okay, so let's do that. So this plus this is 3x. This and this is just y. This cancels out, and this is 4, okay? Now this and this is 4x, this and this is negative 3y, and this is 1, okay? Now what do we do? Now I'm gonna multiply this equation by 3 so I can eliminate my y's, right? Okay? So I'll move back to black so we make sure we can see. This times this is 9x. This times this is 3y, and then never forget to multiply over here, and that's 12. Then we can cancel out here. And we're left with 13x equals 13, so x equals 1. Now I'm going to plug that 1 in up here and get my y. So that's 3 times 1 is 3, plus y equals 4. I minus my 3, and y equals 1. So now x equals 1, y equals 1, and I can use both of those to plug into any of these equations and get my z. So I'm going to use this one. That's 1 plus 2 times 1 is 2 plus z equals 4. 2 plus 1 is 3, so minus 3z equals 1. And then we can check it. Let's check it with another one. Let's check it with this one. 2 times 1 is 2 minus 1 is 1. 1 minus 1 is 0. Bada bing, bada boom, we are right. Okay, let's look at example 2. I already didn't give myself enough room on this one, but oh well. We'll figure out what to do. It's easy to make a quick mistake on adding and subtracting, so just be aware of what you're doing, okay? Here we go. What are we going to eliminate easily? This one we can eliminate super easily, you guys. So let's do that first. Without any manipulation, we can just eliminate stuff in this one. Because we can eliminate the 2y and the 2. So let's do that first. So this is 2x. Cancel out our y's. 2z equals 8, right? Let's see if they do that one with us. 2x plus 2z equals 8. Yeah, they did that one too. I like to check it because sometimes it can get a little confusing. Okay, now I'm going to eliminate. That means I have to also eliminate y's up here. So I'll eliminate this one for y's, which means I'm going to need to manipulate this equation a little bit by multiplying it all by 2. So I can get a negative 2y right here, right? Okay, so I like to know that these are all my originals. I'm going to put it down here, though. That's going to be 4x minus 2y plus 6z equals 2 times 9 is 18. Don't forget to multiply over here as well, all right? Checking our math really quickly. And we got it right. Okay, so then we eliminate. Okay, so remember, we're doing this one with this one. That's x plus 4x is 5x. Eliminate our 2 y's, and so we have 7z equals 8 plus 18 is 26, okay? Now we see what we can do with this one, the x and the z. Both of them are going to require manipulation. So I'm going to try to eliminate the x's. I'm going to multiply this by negative 5, and I'm going to multiply this by 2, okay? So then I end up with a negative 10 here and a positive 10 here, right? So here, negative 5 times 2 is negative 10x. Minus 10z equals negative 40. This and this is 10x plus 14z equals 52, right? I eliminate my x's and I'm left with 4z equals 52 minus 40 is 12. So z equals 3. Okay? Now we're going to put that 3 into one of these to get our x. I'm going to put it into this one right here. So that's 2x plus 2 times 3 is 6 equals 8 minus 6 is 2. 2x equals 2. So x equals 1, right? And now I can use my z and my x to find my y. So let's just use this one up here. 2 times 1 is 2 minus y plus 3 times 3 is 9 equals 9. So that's 11 minus y equals 9, right? Because 2 plus the 9. I put my 11 over here as negative 2, so negative y equals negative 2, so y equals 2. So now we have 1, 2, 3. And we can use another one of the original equation, so I'll use this one down here to check it. That's 1 minus 2 times 2 is 4, so 1 minus 4 is negative 3. Negative 3 plus 3 equals 0, so we know that we are right. Okay, no matter how many steps we had to do there, we can get the right answer. So go ahead and try the practice. Don't get frustrated. Just pick the 2 that you're going to eliminate with. Okay, you can even make your little brackets here to help you keep it in check. And then go about solving poco a poco. Okay, when you get mad at me for this one, remember that it's not my fault. The answers are ridiculous. X equals 8 over 3, y equals 5 over 3, z equals 4 over 3. So when you got the fraction the first time, if you did, you were probably like, this has to be wrong. I was saying it had to be wrong, but it's not, because they're just being mean to you, okay? Okay, look right here. You have, I decided to eliminate with these 2 and eliminate with these 2, right? So this and this and this and this. I manipulated these 2 over here by multiplying this by negative, okay, so that I can eliminate my x's. So I had negative x plus 2y minus 2z, negative 2. Eliminated it with this, so I got 3y minus 3z equals 1. Okay, now I had to manipulate these over here by multiplying this one by negative 3x to eliminate my x's. So I got negative 3x minus 3y plus 3z equals negative 9. I eliminated those and got negative 5y, and I put it over here, plus 1z, negative 7. Okay. Then I decided that I was going to manipulate this one by a 3 to do a negative, to eliminate the negative 3 with the positive 3 here. So I made this negative 15y plus 3z equals negative 21. That becomes negative 12 here, and you eliminate your z's, and this is 1 minus negative 21, so it's negative 20. Divide that by 12, and you reduce down to 5 over 3. I put my 5 over 3 into this equation up here. 3 times 5 over 3 equals 5, minus 3z equals 1. 1 minus 5 is negative 4, divide by negative 3 is 4 over 3. Then I took this equation right here. I did x plus 5 over 3 minus 4 over 3 equals 3. Okay, well 3 is 9 over 3 if we're going to do everything with a common denominator. 5 minus 4 is 1 over 3, so 9 minus 3 minus 1 over 3 equals 8 over 3 for x. Blech, gross, but there it is. Okay, let's go into lesson 91. Okay, this part of the lesson is not too hard. It's just very, very new. It says graph the solution to this. Okay, now you need to recognize that this is in y equals mx plus b form. It's just that we need to pay attention to these things right here. I'm going to show you how to graph them on a graph because these are not number line ones. These are, because it's not just x, it's y equals mx plus b. It's a form of a line. And then you're going to see how you can represent two of them at the same time. Okay, so I'm going to teach it to you with the examples. The very first one, here we go. We need to put, this is our y-intercept, so 1, 2, right? Start right there. Then you have up 1 over 2. Up 1 over 2, or let's go the opposite, down 1 over 2 this way. But look, this is less than without the equal sign, which means you need to dot your line. Okay? Then, so when this is not included, instead of doing this on the number line like we used to do, you just dot your line. Okay? Then this one up here, okay, we're going to start on -3. Then this is 1 over 1, so it's down 1 over 1. Down 1 over 1. Or up 1 over 1, right? But then this one is equal as well, so we're going to put our line like that, okay? Hopefully better than I did. Now you need to decide where to shade it, where to color it in to represent both of these together. On this one, it's less than, so your shading is going to have to be below the line. See that? Abajo de esta línea. But this one is greater than, so it's going to have to be arriba this line, okay? So you have to find the one part in the graph. Is it here? Is it here? Is it here? Or is it here? That is below this line, but above this line. So it's going to be right here, okay? Below and above. So you're going to shade it in there. And you can look at your book and see that that's exactly what they do. Crazy, right? But it actually has a lot of sentido. So go ahead and look at number 2. Oops. Okay, our lines are y is greater than x minus 2. And y is less than or equal to x plus 1. So we start with the -2. Remember that's 1 over 1, that's invisible. -2 is right here. Then we go up 1 over 1. Or down 1 this way and over 1 this way, right? There's no equal sign there, so we have to dot our line. Okay? Then we have this one, plus 1. Up 1 over 1 or down 1 over 1. And look, you see how those slopes are the same? The 1 over 1 and 1 over 1. Remember that means that the lines are going to be parallel? It has to be greater than this one but less than this one. So we're obviously going to shade in the middle. And that's all you do. Okay, so go ahead and try those practices and see if that makes sense to you. Okay, A is going to look like this, and this is why. Your very first line, you start on -2. You go down 1 over 1 or up 1 over 1. It's a solid line because of the equal, and it has to be above that. So wherever your shading is going to be above this line. It's going to be greater than this line, but we don't know exactly where yet until we get the other line. This one also started at -2, but it went up 1 over 3 and down 1 over 3. Solid line this way, but it had to be less than, so now it has to be on this side. So the only part of this that's above this one but below this one is right here. This one ended up being parallel again, -3 and then up 1 over 1 and down 1 over 1. And this one was +3, up 1 over 1 or down 1 over 1. Solid line, so it has to be in the middle because it's greater than this one but less than this one. Okay, if you have any questions, just let me know. Bye, guys.